Okay. All right, so we're in the Animalia still. We're in the Bilateria, which means now we have to figure out what's going to happen to that blastopore. So now we've switched and the blastopore isn't becoming the mouth anymore. Now the blastopore is becoming the anus. So the mouth forms second. So we're in the mouth, deuterostomia. And this is where we find ourselves, and I mean that not just in terms of curriculum, but you and I, we are chordates. We are in the phylum Chordata. And just in case you're curious, because you might think, I'm a vertebrate. Well, it turns out that the vertebrates are a subphylum of the Chordata. So if this is our pie chart of the Chordata, we've got two subphyla that are relatively small. We've got the Cephalochordata, and we've got the Chordata, which I'm going to talk about first. And then everything else in here, which is like 90-something%, are the vertebrata. So the vast majority of chordates are vertebrates, but there are these two invertebrate subphyla within the Chordata. And in order to be a chordate, we are looking at 4 synapomorphies shared by all members of Chordata. They are, in no particular order, I'm just going to number them 1, 2, 3, 4, having a post-anal tail, meaning that at least at some point in the life, there is a tail and it extends beyond the anus. Think about the earthworm and how the anus was at the very end of the animal. So we think of that posterior end of the animal as being the tail, but the anus is at the very end of it. A notochord is a stiffened cartilaginous rod that gives the animal some stiffness and helps to direct movement. A dorsal tubular nerve cord. So contrast this with what we saw in the protostomes, where a lot of them had pairs of ventral nerve cords that were linear. Now we've got a dorsal nerve cord that's also arranged into a tube. So that's different. And then the last one is some type of pharyngeal gill slits. The pharyngeal means related to the pharynx, that's the throat. And you might look at these things and be like, I do not know. If you asked me to point to these things on my own personal body, I wouldn't know where to look. And that is true, that it's hard to kind of just point these things out. But many of these things become modified, or we find that they only exist in the animal during part of their life. So both of those things are happening, and I will get to how that works later. Okay, so let's look at the subphylum of Chordata. Cephalochordata. And that means notochord in the head, like a cephalopod, cephalopoda, like squids and octopuses. Those have a head and they have a foot. Cephalo refers to the head, or cephalothorax, like we saw in crustaceans. Cephalo means head. Chordata refers to the notochord. And members of the Cephalochordata, there's not that many of them. We have one genus that I know of. We used to call it Amphioxus. Now the name is Branchiostoma. And these are lancelets. These are relatively small fish that have no fins. They look kind of fish-like. And, well, they're relatively small, just a few centimeters long. And we're going to draw one here. Kind of the post-anal tail is kind of diamond shaped. Okay. All right. So, I'm going to start drawing here. There's going to be this cavity here. And you might say, aha, we've got a mouth and we've got an anus. But nope. Notice I haven't labeled anything yet, so don't you label anything yet. And I'll get to why in a moment here. Inside this structure here, which it does turn out is the mouth, we're going to find that this, in fact, inside the mouth, we have this structure. So we have this kind of opening into this chamber, and this chamber is called the atrium. And you might have heard this word atrium before, referring to as a room in a building. Usually it's like if you go into a big skyscraper, the first room you go into is the atrium, and that's kind of the room that welcomes you into the building, and it's large, and then it diverts you into any of a number of different directions, to the elevators, to offices, whatever. So this atrium kind of does the similar thing. This is where food enters the body, and it's kind of a large chamber. Your heart has atria as well, and we'll get to that later. But in this case, the atrium is it's a little bit different from the mouth because it has its own private kind of opening called the atriopore, which is not the anus, it's something different. So what's going on here? Well, this second line that I've drawn going through here, that is actually the gut. So inside the mouth, inside the atrium, you notice I've drawn this kind of widened out area here. And this is called a pharyngeal, we'll call it a pharynx, with gill slits. Okay, so these are filter feeding animals. They live kind of in shallow marine habitats. And they don't have any limbs to kind of shovel food into their mouths, so they kind of have to filter feed, which means they take seawater into the atrium, and then most of that seawater is just water, so it needs to kind of pass through and doesn't have any nutrition to it, because we don't want to like, have these things blow up like balloons full of seawater. So the atriopore lets the seawater go out. But if there's any good little bits in there, things to eat, like little plankton and vertebrates, things like that. My dogs have discovered something. Then those bits of food get stuck into this pharynx, which acts kind of like a filtering, like a sieve. So food particles get filtered out through the slits in this pharynx, and then the food goes through this gut into a stomach, and then that is what ends up getting digested, and the waste leaves through this anus, which means this area back here is our post-anal tail. Post as in posterior. This is the posterior end. This is the anterior end. This is the dorsal side. This is the ventral side. Okay, so we've been able to feed this thing and figure out that part. Need to figure out something else, which is, how does it move? Okay, so now coming about just a little bit above the midline in the dorsal direction, just a little bit above. We're just going to draw essentially a thickened line. Leave yourself some room to the dorsal side here. We got to put something else in here. Now this thing here is a long cartilaginous rod, which is the notochord. So that gives the animal some stiffness. So typically they'd be found kind of like with their mouth sticking out of the soil at the bottom of the ocean, shallow ocean. But it does need this notochord to provide stiffness. That's what cartilage does really well, is it stiffens. Okay, and then just dorsal to that, you can even draw it like this. Doesn't need to go all the way to the into the tail, quite as far. This is going to be our dorsal tubular nerve cord, okay? So notice we've got a CORD and a CHORD. They're two separate things. I'm not exactly sure why we have two separate types of cords spelled that way, but it's important that we do have them. So I'm going to call a dorsal tubular nerve cord henceforth a D, T, and C, dorsal tubular nerve cord. But notice that that is a little bit dorsal in the dorsal direction compared to the notochord. So they are separate things. When we get into the vertebrates, things kind of change. But for now, we do have a dorsal tubular nerve cord and a notochord. So here we see a simple animal, an invertebrate chordate that has all four of our synapomorphies of the chordata, and it retains them throughout its life. So when they're larval, they're tiny little, just babies hatched, all the way to when they are adult animals. This is an adult lancelet. They retain all four of these characteristics, and that's something that we don't always see extending throughout the life of the animal. Okay, see you next time.